Good morning, guys. We are moving on, and this is really our first lesson. Well, it's actually the second, but the first record lesson about graphs, trig graphs. So this is the last part of trig, and I think trig graphs are a bit easier at this point. Okay. Now, last lesson I gave you a whole lesson just to draw a sin and cos graphs by just finding the value of these sin and cos for different angles from 0 to 360. Let's start by trying to identify which graph is which. Which one is the top one? Is that a sin or not? That's a sin. Okay? So if this is, let's say, theta, that is really sin theta. And that means you guys realize that this one is a cos theta. And we said that they're very similar. It's kind of like basically one is shifted to the other. So I already mentioned to you that really this carries on. This graph carries on. Okay? So you can see that if you carry that on and you cut from here to here, the sin graph is just like the cosine graph. Okay? Right, I'll pause here because I can see some questions. Right. So what we're going to do today, we're not going to do the tan graph today. We'll leave that for a bit later. What we're going to do now is a stretch and shift. Okay? These, and really this is actually a really good preparation for our next topic. Our next topic is function, where we're going to look at function and their graphs that are related to them. And we're always going to start with what I call the mother graph. It's like your basic graph. In this case, actually, there's a mother and a father. Okay, so these two graphs you need to be sketched in your brain. You really need to remember what to look like, because now we're going to start playing with them. Okay, so if this is, as I said, we call it y equals sine theta. My question will be, let's see if we can draw, how can we draw y equal 2 sine theta? I'm just thinking now, sorry, before we do that, okay, so we know where we're going, but we need to put in some numbers. We need to put some numbers. So what, I mean, this is 0, obviously. What is this number? What angle is this? When is this? It's 180, you're right, and this is 360. Okay? Now, that will be 90 and 270. Okay? Right here, okay, let's leave this for a second. Now, when the angle is 90, what will be the value of sine?
1.
That will be 1. And when the sine is, let's do
-1.
it will be -1. So we already said that this sine graph swings between 1 to -1. Okay? Let's have a look at cosine. Okay, so that's obviously 0. That's, you can imagine, probably is 360. So what will that be? 90. And you remember I showed you that diagram, y cosine 90 is 0. I'm not going to do that again. That means this is 270. And this will be, sorry, yeah, that's 180. And this will be 270. Okay, cool. So now I'm back to y equal 2 sine theta. Leo, you want to say, what would it look like?
Yes, I think it would, the highest point would be at 180.
It will be at 180.
Yes.
Okay, so it's going to go up like that.
No, not higher, just longer.
Just like this.
Yes.
Good try, but incorrect. Okay. Let's think about this. What does this 2 do? What does the 2 do? It multiplies everything by 2. So when sine theta is 0, what is 2 times 0? 0. So it's going to stay 0. Okay. When sine 90 is 1, what will be 2 sine 90? 2. So I'm going to put a 2 here. So there's going to be a point here. There's going to be a point there. When sine 0, again, sine 180 is 0, 2 times 0 will be 0. So it's going to go up here. It's going to go up there and come down here. What will be the situation? It will be -2. You're right. Okay. When sine 270 is -1, now it's going to swing down to -2. So there'll be a point there and it's going to go up here. So what we're doing to this graph, and I didn't really draw it as nicely as I would like, is a stretch. This is a stretch. Okay? It's a stretch. Okay? The way to draw graphs, and that's what you're going to be doing for me today, is just as I did now. You start by finding the value at specific points and then try and draw the graph without, so it won't be pointing. You want to make these things round. Okay? All right. We're going to carry on. What about if I have y equal half sine theta? What is that going to do?
Shift it.
It's gonna make it smaller.
It's going to compress it. We're going to wait with the shift. Okay, we're doing just the stretch first. It's going to make it smaller. Okay, so again, when sine 0 is 0, half times 0 is 0. But when sine 90 is 1, what will be half times 1? 0, 0,5. So it will be 0, 0,5 here. And then here it's going to go back to 0. And here, instead of going to minus 1, it's going to go to minus 0, 0,5. And back to 0. So that is going to be that stretch. Okay? Let's do one more. Now, because this is already too much, so we're loading it up too much. I'll just pause here for questions. Okay, so we played a little bit with the sign. We're stretching it. When I say stretch, really it can be either stretch or really could be compress. Okay, if that number in front of the sign is larger than 1, it will be a stretch. If that number is smaller than 1, it will obviously be compressed. Now with the cos, I could do the same, but actually I want to do something a little bit different. I'm going to put a negative number in front of the cos. Okay, so let's leave the sign for a second. 0.2, is that larger than 1 or smaller than 1? Smaller. So is it going to be a stretch or compress? Compress. It's going to be squashed, right? Now, what is the minus going to do? I just want to see if you can have an idea, yeah? It will flip it, you're right. Okay, and I'll explain why. So the way to kind of do it, especially in the beginning, before you get really confidence how it works, is just like I said, just try. You can put it in a calculator. Yeah, we don't even need a calculator. You put the different values of 0, or minus 0,2 cosine theta for 90, 180, 270, 360. And how do you do it? You just multiply minus 0.2 by the value of cosine theta. So when theta is 0, cosine theta is 1. So then I need to multiply by minus 0.2. So what will be the answer? Minus 0.2, which is like somewhere here. Right? If this is 0, this is 1, minus 1, this is 0.5, this will be roughly minus 0.2. So I'm going to have a point here. This point here went down to here. You happy with that? Right. When cosine 90 is 0, so what is minus 0.2 times 0? Still 0. You see, whenever this is 0, the other one stays 0. Also here. It's always touching the x-axis in the same place. Right. When cosine 180 is minus 1, what will be minus 1 times minus 0.2? Positive 0.2, which is like somewhere here. So I'm going to have a point there. Can you see it? And then a 270, what I can do without thinking, it goes back to 0. Whenever this is, the blue one is 0, the black also goes to 0. And then cosine 360 is plus 1. Time minus 0.2 will be? Minus 0.2. So somewhere here. Okay? So what we're going to have is something like this. Okay? And this is, if you look at it, it's just like you guys said, it's a compressed graph. Okay? We compressed it. But like Leo said, it's all flipped. What does it mean flipped? You just, every time this is plus, now this is minus. Every time this is minus, this goes plus. You basically, what you've done, you swung it around. Imagine that this blue thing, okay, you just swing it around like that. Okay? Maybe what I should have really started, and I will do it now, is what if I had y equal minus cosine theta. Right? So cosine theta just got minus. Exactly. So if I compare the blue and the purple, there's no stretching, there's no compressing because there's a 1 in front of the cosine theta, but there is that minus 1. So I'm just flipping it. So the positive 1 becomes negative 1. The 0 stays 0. The minus 1 becomes positive 1. The 0 stays 0. Plus 1 becomes minus 1. Okay, maybe that's what I should have started with. And then you connect the dot. You're trying to make it nice and round, nice and fat. You know, you don't want these pointy ones. You don't want it to be like that. Okay? And now you can very see that the blue or the purple line is basically the same as the blue line, just as if you could twist it around. Imagine this is a skewer. You know, this is a skewer and you're just twisting it like that. Are we happy with that? Okay, I'll just pause for a second if you've got any question, and I want to. Okay, so before I send you to do some work, I want you to learn the word, well, a few words. Okay, range. Okay, range is the value of angles that you're using here. What values of angle are we using here? From 0 to 360. Why am I doing these straight brackets? What does that straight one? Do you remember the square brackets? What does that mean? We learned that earlier in the year.
Included.
It included. So 0 is included there. And 360 is included. Okay? Okay? Right. Minimum and maximum. What does minimum and maximum do reckon mean?
The least and the most.
Yeah. Okay, so if I'm looking at the black graph, y equals 2 sine theta, what will be the maximum value of y? 2. So the maximum value is 2. What's the minimum value? Minus 2. Okay, so that kind of makes sense. But the new word, well, maybe you learn it in science, is amplitude. I should have written it.
Yes.
Okay, you've learned about amplitude? Okay? Okay, those of you who've done science have learned about amplitude. What is amplitude?
The distance from the equilibrium to the... How do you know this, Ani?
So, one of the ways of describing amplitude is like the height of the wave. So it's the highest part, the distance from the highest part, like Oli said, to the equilibrium. So the equilibrium is here. So the amplitude will be 2 minus 0, which is 2, right? Yeah. For the green one, what will be the amplitude? Just 0.5. 0.5 minus 0 is 0, okay? For the amplitude of the blue one, which was green one, the black one, sorry, 0.2 cosine theta, what's the amplitude? 0.2. But in maths, in the textbook, the way they define it, it's the same way, but they write it like this. It's half times maximum value minus the minimum. I want to just show you it's the same thing. So let's take the blue one. Okay, the maximum. What is the maximum in this case? 1. Okay, the maximum is 1. The minimum is minus 1. So it's minus 1. Okay, 1 minus 1 time half. Okay, because that's the definition of the amplitude. So what is half? It's half time. What is 1 minus 1? 1. 2. So half times 2 is 1, which we know that the amplitude really is 1. Okay? Does that make sense? Now, personally, I use Oli the way you learn in science. I just look from the highest point to the equilibrium. But you will see when we learn about shift that sometimes is a little bit tricky. It can still be done, and I use it. But that's the method that the textbook tells you. Take the highest value. Let's do this one. Let's do for the black one. Okay? Okay? So what is the amplitude? Okay? It's going to be, first of all, you put half. And then you write down, what's the maximum? 2. Minimum? Minus 2. You just got to forget that minus. Okay? And that's going to be half time. What is 2 minus 2? 4. So the answer is 2, which is the same thing as...
So it would always be the half.
Yes. Because why is that half? What we're asking is, what's the difference between the maximum and the minimum? But the difference between the maximum and the minimum is like double the amplitude, right?
Yeah.
Because you're going from the peak to this thing, you call it the trough. So I want half of that, because I want, like Oli said, I want the distance from the maximum to the equilibrium, or the minimum to the equilibrium. So I'm just finding this difference and halving it. Okay, I'll just pause for more questions. Periods. Okay, one more thing we need to explain. What is the period? Okay, what I tried to explain a few times, even though I don't always draw it, that these graphs, the sine and cosine, they don't stop at 360. The range that we're working with is from 0 to 360, but they carry on, and we will extend them definitely next year. Okay, if I carried on drawing it, it will carry on looking like that. Okay, so in other words, these sine graph and the cosine graph repeat themselves. Do you understand what I'm saying when they say they repeat themselves? Okay, So that sine, that's another sine. Okay? That's like a whole, if you learn science, you'll say this whole thing is the wavelength. Okay, have you learned about wavelength?
Yes, sir.
Okay? So when they ask me what the period is the angle where the graph start repeating itself. Okay? So we've done one cycle and we're starting another exactly identical cycle. What will be the period in this case? 360. Okay? You can see here, this is one cycle of wave. Now it's starting to repeat itself. Now the good news, okay, that all in grade 10, all the periods of all the graphs you work with are 360. You can see the same thing that happens here, right? Okay? Right? So at 360, the graph repeats itself. But the issue that some people might have, I did hear someone say 180. Okay? But you can see that this part is not the same as that part. Can you see it? This is going up, this is going down. So that is not a repeat of this, definitely not a repeat of that one. Does that make sense?
Yes, sir.
The period is not 180, the period is 360. Now, I'm just going to draw you just for once. Like I said, you're not going to do it this year, but next year you will need to do it. Sometimes the periods can be less than 360. So for example, I can draw something like this. Okay? This is another graph. It's another sine graph. Okay? What will be the period here?
180.
180.
180. Look at this. If I take this, take this, copy and paste. And paste. Okay? I'm recreate the same graph. Okay? The period here is half. And this is what Leo said. If you remember in the beginning, he said when I put the 2 there, what he said to me, the period changes. And you weren't right, but if I put the 2 in somewhere else, then you would be right. And we will learn that next year. Okay, I'm going to stop here. I'm going to do a different video for the shift. And I'll answer your question.